Okay, welcome back to the physics class, my dear students. So, as you know that in the previous class, I was discussing regarding the expression for the resultant of two concurrent vectors. So, in that, I just derived the resultant formula. That is what? Just we derived and used the formula, that is vector is equal to square root of a square plus b square plus 2ab cos theta. This was the formula that we derived in the previous class, which gives the resultant of two concurrent vectors. It is a resultant for the two vectors which are having the same initial point. These are the two vectors. This is a resultant of two vectors which are originating from the same point. Okay, so even though this is not still completed, still we should move towards the expression for the alpha. That is what, my dear students, yesterday you might have observed, that is what in the previous class you might have observed, that I said alpha is the direction of resultant vector. So to derive that, I am just going to write the diagram again. So see the diagram. So I am just going to consider the two vectors. Let us call these two vectors as A and B. So I am just considering this as a vector A and this as vector B. So just I am writing in this way, small a and small b. So my dear students, AB is said to be a vector B and AD is said to be a vector A. Now the resultant of these two vectors, is called as resultant vector R. So the angle which is present between the vector A and the vector B is taken as angle theta. And my dear students, the direction of this resultant vector of these two concurrent vectors is taken as alpha. To derive, to continue for calculation of this tan alpha value, I am just going to extend this vector A. I am just extending this vector A. Now, see, I am just going to join this BC, whereas AC is the resultant vector capital R. And similarly, I am going to join CD. Also, right? Now, let us write a perpendicular to DE from C. Please be careful. Here, AB is equal to B vector, AD is equal to A vector, AC is equal to the resultant vector capital R, and this angle theta is the angle between the two vectors A and B, and alpha is the direction of the resultant vector capital R acting along AC. For my calculation, I just extended this AD, that is vector A, up to E, and then I just drawn a perpendicular from C to AE, right? So finally I got it this way, I got the diagram in this way. Now let us see carefully. So my dear students, if this is B, that is what AB is B. So that AB is parallel to CD. If AB and CD both are parallel, then if this is vector B, then this should also be equal to vector B. Right. Similarly, if AD is vector A, then BC is also considered as vector A, because BC and AD both are parallel to each other. Now, I am just moving towards the finding of, to find the resultant. See, it is a continuation of the previous class. In the previous class, I written the same diagram. Don't write the same diagram in your book. So the same heading we have, but already I derived up to this point, that is vector is equal to square root of a square plus b square plus 2AB cos theta. But now I'm just finding out the direction. So just continue with this heading. Don't write all these things again. Just continue with this heading to find the direction of resultant vector. Yes, done. See, from the triangle, so which triangle I am considering? ACE. I am using the triangle ACE because there only I will get an angle alpha. ACE. Therefore, in that I am calculating tan alpha. You know from mathematics, tan theta can be written as opposite by adjacent. So here this is said to be opposite and this side said to be the adjacent. Opposite is CE, adjacent is AE. So EC divided by AE. Right. How to write this AE? AE can be written as AD plus DE. AD plus DE. Right. I'm just finding it out here. EC divided by AD plus DE. So my dear students, already you might have found the value of EC and DE in the previous class. So that what you found? So that the value of EC is equal to DC sin theta and value of DE is equal to DC cos theta. This is what you calculated in the previous class. You can just turn the page and you can see that. So this is what you have derived. So now what is DC here? DC is equal to B. And what is AB? AD is equal to A. AD is equal to vector A. Now let us substitute all those values in this equation. So that tan alpha is equal to EC is DC sin theta divided by what is AD? AD is vector A plus what is DE? Again it is DC cos theta. Let us move for one more step. So here it is DC. What is the value of DC? It is B. Just substitute the value. So B sin theta divided by A plus B cos theta. This is what we got, right? So now I want to calculate only alpha. I don't want to calculate the tan alpha. So my dear students, here it is tan alpha, right? Tan alpha is equal to B sin theta divided by A plus B cos theta. See how I am writing? Tan alpha is equal to B sin theta divided by A plus B cos theta. But I want alpha. So what happens? Tan ikkade kalsidre enagutte? Inverse agutte. One, the tan function or the sine function or the trigonometric function which is towards one side. If you are going to shift that trigonometric function to the other side, it becomes inverse. So that alpha is equal to tan inverse of, I will just write here itself, you can write it in the next line. So tan alpha is equal to tan inverse. So what is there here? Here it is with B sin theta divided by here. What is there? You have A plus B cos theta. Okay, hope you got this, dear students. Put this formula inside the box, whereas this alpha exactly shows you the direction of the resultant vector. Whereas alpha is angle which shows the direction of resultant vector. Theta is the angle which is exactly present between the two vectors, that is what the vector A and the vector B, where the two vectors are called as the co-initial vectors which are having the same originating point, or you can say that these two are also called as the concurrent vectors. Dear students, whereas A and B are this concurrent vectors, and now you are just moving towards the just go for noting down whether the OR is maximum and when the OR will become minimum. So that for calculation of that the OR becomes minimum or the OR becomes maximum, we have some considerations. That is what we should substitute the value of theta. So you can observe that here we have r is equal to square root of a square plus b square plus 2ab cos theta. So my dear students, when we just came to the school for the correction purpose, I observed that some of you members written up to the motionless right line. So it's not good. So just write the entire thing that what we are discussing. So if once the video is posted in the classroom, go through the video and try to complete the notes. And I just observed some of the students really good. What they did is they return the points notes as well as they return the PDF notes also. One thing I will say, why? Because it takes a lot of time. It is time consuming and also it creates a confusion in your mind. Why? Because here I am explaining in a very easier way, so that what we provided as a PDF notes, that's also very good notes that we provided, so that it is for the extra information, so that whatever we people are just teaching here, so nané path ಮಾಡ್ತಿರ್ತೀನಿ. So note down ಮಾಡ್ಕೊತಾ ಹೋಗ್ತೀರಾ. So some sentences ಹೇಳ್ತೀನಿ, sentence miss ಆಯಿತು, ನಿಮಗೆ ಕೇಳಿಸ್ತಿಲ್ಲ ಸರಿಯಾಗಿ, so some problem you might have faced ಅಂತ ಅಂದಾಗ PDF ನೋಟ್ಸ್ನ ತೆಗೆದಿಟ್ಕೊಂಡು ಆ ಪಾಯಿಂಟ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಅಲ್ಲಿ ಜಾಯಿನ್ ಮಾಡ್ಕೊಳ್ತೀರಾ, ರೈಟ್. ಸೊ ಇಲ್ಲೇನಿದೆ ಅಲ್ಲಿಲ್ಲ ಅಂದರೆ ಅದನ್ನು ಕೂಡ ಜಾಯಿನ್ ಆಗುತ್ತೆ. ಸೊ ಒನ್ ಥಿಂಗ್ ಆಲ್ಮೋಸ್ಟ್ ನಾವೇನು ಹೇಳ್ತೀವೋ ಇಟ್ ಕವರ್ಸ್ ಮೋರ್ ದ್ಯಾನ್ ಎನಫ್. ಸೊ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದಿಸ್, ರೈಟ್. ಸೊ ಒಂದು ಯಾವ್ದಾರ ರೆಫರ್ ಮಾಡಿ, ಸೊ ಪಾಠ ಕೇಳ್ತಾ ನೋಟ್ಸ್ ಬರ್ಕೊಂತ ಹೋಗಿ ಇಟ್ ಹೆಲ್ಪ್ಸ್, ತುಂಬ ಈಸಿ ಆಗುತ್ತೆ ನಮಗೆ, ರೈಟ್. ಸೊ ನಾವು this completes the expression for the resultant of two concurrent vectors. Now my dear students, I am just moving towards discussion of when the resultant vector becomes maximum and when the resultant vector becomes minimum. So take it as a note in your notebook. So in my notes note as already. So that the first note I am just writing here. The first note, when theta is equal to 0 degree. What is this? Theta is angle between two vectors. It means if the angle between the two vectors is equal to 0, then what happens to the resultant? So let us see that. When theta is equal to 0 degree, so what it is going to show, what happens to the resultant? See my dear students, we know that r can be written as square root of a square plus b square plus 2ab cos theta. So in place of theta, we should substitute 0. So what is the value of cos 0? So you know what is the value of cos 0? I think you know that sin 0 is 0. Sin 90 is 1, 0 to 1 and 1 to 0. So cos 0 becomes 1, right? Cos 0 becomes 1. So then which is equal to, r is equal to, see I am just writing it out, square root of a square plus b square plus 2ab. So what is the value of cos theta? That is cos 0, which is equal to 1. So 1 into 2ab is 2ab itself. I am not going to change anything here. So now it is in the form of a square plus b square plus 2ab. It means we can write the formula with the help of mathematics. That is, this can be written as a plus b whole square. So if I just cancel the square and square root, then the resultant vector r is equal to the sum of the two vectors a and b. Sum of the two vectors a and b. My dear students, I am just not writing here the arrow mark. Why? Because I am just calculating the magnitude, right? I am not calculating the direction. If I am calculating the direction, we have the formula that alpha is equal to tan inverse of b sin theta divided by a plus b cos theta. But here we are calculating the magnitude, so I am not putting the arrow mark. Nange arrow mark aagta illa. And now please be careful. So the magnitude of a resultant vector r is equal to the sum of magnitude of vector a and vector b. So let us see whether this is maximum or whether this is minimum. So before going to conclude that which is minimum and maximum, there is another one case. So I am just moving towards the discussion of that case. So suppose when theta is equal to 180 degree, what is the value of cos 190? So cos 190 is equal to minus 1. So from the trigonometry formula, the cos 180 value is equal to 1. Then what happens to the resultant vector? You know that the resultant vector can be written as a square plus b square plus 2ab cos theta. Whereas in place of cos theta, we have minus 1, right? I am just writing it as minus 1. So minus 1 into 2ab becomes minus 2ab. Now dear students, here it is in the form of a square plus b square minus 2ab. With the help of mathematics, it can be written as a minus b whole square. Square root cancel with each other. Then what is the magnitude of the resultant vector? It is equal to a minus b. Please be careful. Here we got when the angle between the two vectors is 0, we got r is equal to a plus b, and when the angle between the two vectors is said to be 180 degree, we got that the resultant is equal to a minus b. What this indicates? Here the resultant is equal to sum of the magnitude of the two vectors a and b. Here the resultant is equal to the subs. That is what the difference between the magnitude of two vectors is a and b. If we add, definitely we will get the greatest magnitude, and if we subtract, we will get a less magnitude. So that the resultant when the angle is 0 degree is maximum and the angle is 180 degree, then the resultant is said to be minimum. So this is what we deduced, my dear students. So that from these two notes we came to the conclusion that when the angle between the two vectors is 0 degree, the resultant becomes maximum and the resultant becomes minimum when the angle between them becomes 180 degree. So in your book, so I am writing it case 1, the apology complete by the so it gives maximum resultant and the very last year. So here the case 2 last minimum resultant ಅಂತ mention ಮಾಡ್ತೀರಾ. Right. Hope you got this one. Yes. Okay dear students, not only this, even now we are moving towards the two famous products. So that is what is scalar product and vector product. My dear students, we have just observed that the addition of vector. So that how many methods are there for adding of the vectors? For adding of the vectors, we just did the two methods. One is triangle law of vector addition and the second one is parallelogram law of vector addition. But even with that, we just come towards the deduction of this resultant vectors. So then to observe this resultant vectors in the next, we are going to resolve the vector also, and here also we will use to find the resultant of those two vectors which has been resolved into two components. But before going to discuss all such things, first we should know one thing, that is what how many types of that is what the product of the two vectors are there. See, we just added the vectors, we subtracted the vectors, then how to do the product of the vectors? See, addition is over, subtraction is over, so as well as then what about the product of the two vectors? See, if we have a and b vector, we can add them and we will get the resultant vector as r is equal to a plus b. Similarly, if we want to subtract the vector, so we are just going to add minus b vector with a vector, or we are going to subtract the b vector from a vector, so that the resultant vector becomes equal to a minus b. So hope my dear students you got that what I am saying. So already we just completed addition and subtraction. Now we are moving towards the discussion of product of vectors. See, while doing the product, we have the two products, two types. One is scalar product of two vectors. So another one is vector product of two vectors. My dear students, first let us discuss the scalar product. Dear students, whereas the scalar product is also called as dot product. Scalar product is also called as dot product of two vectors. So we have a statement for this. Yes, we have a statement to just to explain this, my dear students. While defining the scalar product of two vectors, suppose assume that we have the two vectors, say A and B. Then how to multiply those two vectors. So multiplying of those two vectors can be done simply just by A into B. It's very easy to say, but it's very difficult to come to the conclusion when we are discussing regarding many physical quantities and madam physical quantities. So now work done anta define ಮಾಡ್ತೀವಿ, velocity ಅಂತ define ಮಾಡ್ತೀವಿ, force ಅಂತ define ಮಾಡ್ತೀವಿ. See, work done ಅಂತ ಬಂದ ತಕ್ಷಣ scalar quantity ಅಂತ ಹೇಳ್ತೀವಿ. When we come towards the force, it is a vector quantity ಅಂತ ಹೇಳ್ತೀವಿ. But while writing the formula for this work done, will write simply that force into displacement. Ali observe madri, force is also a vector, displacement is also a vector, but ನಾವು ಏನು ಮಾಡ್ತಿದ್ದೀವಿ, ಎರಡನ್ನೂ ಕಂಬೈನ್ ಮಾಡಿದಾಗ ನಮಗೆ ಬಂದಿದ್ದೇನು, ಎರಡನ್ನೂ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ what we get, work done. But work done is said to be a scalar quantity. Why this is going to happen? See, my dear students, to understand this very carefully, we should know what is a scalar product of two vectors. So that what we are doing, what we are multiplying, keep in your mind, we are not multiplying the directions, we are multiplying the magnitudes. We are multiplying the magnitudes. Suppose if I consider that the two vectors, so let us say that the vector A and the vector B, and the angle between these two vectors are theta. Then how to multiply these two vectors? My dear students, the scalar product of two vectors. The scalar, this is the definition of scalar product. Scalar product of two vectors is defined as the product of the magnitude of the two vectors and the cosine of angle between them. Yes, this was the definition for the scalar product. Okay, good. So just we return the definition for the scalar product. Then how to write it mathematically? How to represent this mathematically? So you said, madam, we have the two vectors, right? Let us see the angle between the two vectors, right? Then how to multiply this? How to write this? Dear students, please be careful. So here you are just writing the scalar product of two vectors. Dear students, the scalar product of the two vectors is represented in this way. That is, A is a vector, B is a vector. So in between, so if we are multiplying that, so you should put a dot here. You should put a dot. So if the dot is present, it indicates that it is a scalar product. So that even we are calling it as a dot product. So A dot B, that is what the vector A is multiplied by vector B in our mathematical sense. So that here in physics we should not use it that way. So vector A dot vector B, or a scalar product of two vectors A and B, or a dot products of two vectors A and B, which is equal to, see how it is defined, product of magnitude of two vectors. What we should multiply now? So we should multiply, this is equal to the magnitude of two vectors A and B. So it means we have the two vectors. For those two vectors, I am just multiplying the magnitude. Magnitude of vector A and magnitude of vector B. I am not multiplying the directions here. And cosine of angle between them. Cosine means cos of angle is theta. Theta is angle between the two vectors. This is a representation of scalar products. Put it in a box. So that vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos theta. That is what the product of the magnitude of the two vectors and cosine of angle between them. Then how to explain this in detail? My dear students, if see, you can write that here after the definition Adhanantara, write one line. So that if the two vectors, vector A and vector B, acting at the same point with an angle theta between them. So write this statement, then write this line. Okay, then write this line. So what's the example for this? I already said you that the work is said to be the scalar quantity. So my dear students, I am not giving you a complex examples. Why? Because if I just give now itself a complex examples, so still you have not studied about the torque ಬಗ್ಗೆ study ಮಾಡಿಲ್ಲ, angular momentum ಬಗ್ಗೆ study ಮಾಡಿಲ್ಲ. All those quantities will come under here for especially when you come towards the vector product and all. So our examples are ಕೊಟ್ಟಿದ್ದಾರೆ. So we just giving you the simple examples so that it's helpful for you to just recall the concept. So here I am just giving you the work done as a scalar product. So how to define this, my dear students? Work done is a scalar product which is equal to force into velocity. See here how I am writing it. Force dot velocity. Sorry, force into displacement. Force into displacement. So in the displacement can be written as S or X, no problem. Force into displacement. But be careful, my dear students. I am just multiplying the product here. So that is what W is equal to F vector dot X vector dot product of force and displacement. Work done is a scalar quantity which is equal to the dot product of the two vectors, that is F and X. See, the vector is multiplied with the vector to get a scalar. So vector is multiplied with the vector to get a scalar. Force is a vector, displacement is a vector, but we will have to get work done as a scalar quantity. And now how to write this? So still we should write it in this way. So that F magnitude of vector F magnitude of vector X into cos theta. Otherwise simply you can write it as Fx cos theta. So I am just showing you the different ways of writing the scalar product. So W is equal to F vector dot X vector. So this can be explained with the help of a scalar product definition. So that the magnitude of X into magnitude of F into cos theta is simply can be written as Fx cos theta. So my dear students, I am just using the magnitude here and I am not using any kind of the direction. Keep it in your mind. And as a force is a vector quantity, X is a vector quantity, that is displacement is a vector quantity. So I am multiplying the two vector quantities which gives you the scalar quantity. That is what is called as a scalar product of two vector. It means if we multiply the two vectors, we will get a scalar product. So that multiplying of two reactants gives you the product, right? So that is what in chemistry reactants and products will say in the same way. Here we are just multiplying the two vectors to get a scalar as a product. Okay, now just in the next line write where F is the force, in the next line write X is displacement and theta is the angle between force and displacement. Hope you are writing. After this in the next line write where F is the force, X is the displacement and theta is the angle between force and displacement. So this is about the definition and the formula related to the scalar product. So my dear students, even we can explain the scalar product with the help of different angles. So that is, suppose when I just written that the two vectors right here. So I just show you the two vectors. So take a note. Yes, and this the first point. See my dear students, suppose if the two vectors that is vector A and vector B, right? See here, that vector A and vector B. The angle between the two vectors here, vector A and the vector B, vector A and the vector B. We have the two vectors, vector A and vector B. But the angle between the two vectors is 0. So if the angle between the two vectors is said to be 0, then what happens to the scalar product? Then, see dear students, the scalar product is A dot B vector can be written as magnitude of A into magnitude of B into cos theta. So whereas cos 0 is 1. So that what happens? A vector dot B vector is equal to AB. Cos 0 is 1. So 1 into AB is AB itself. So that A dot B vector you got it as AB. So this is what the finally we got from the first table. Similarly, let us see the next one. Suppose if the two vectors which are having same originating point, so they are said to be perpendicular to each other. That is what the angle between those two vectors is equal to 90 degree. And ಎರಡು ಮಧ್ಯೆ ಇರತಕ್ಕಂತ theta ಏನಾಗಿರುತ್ತೆ 90 degree ಆಗಿರುತ್ತೆ. It means two vectors are mutually perpendicular to each other. Then what happens to cos 90? You know that the cos 90 is equal to 0. Then what happens to the scalar product A dot B? You can observe that carefully. What happens to this? It becomes AB cos 90. So cos 90 is 0. 0 into anything is 0. So that the scalar product of the two vectors is equal to 0 when the two vectors are mutually perpendicular to each other. And the scalar product of two vectors is equal to the product of the magnitude of the two vectors A into B when the two vectors are having when the two vectors are exactly parallel to each other. So that the scalar product is maximum here. The scalar product is maximum when the angle between the two vectors is equal to 0 and the scalar product is minimum when the angle between the two vectors is 90 degree or when the two vectors are mutually perpendicular to each other. Then my dear students, you know that already in the previous class we said that along x-axis I cap is a unit vector, along y-axis j cap is a unit vector, and along the z-axis k cap is a unit vector. So while we are multiplying the two vectors, sometimes the vector A is along x direction and vector B is along y direction. So you can observe that here the vector A and vector B both are along the x direction. It means for vector A the unit vector is for vector A the unit vector is I cap, and for the vector B the unit vector is I cap, because both the vectors A and B are moving in the x direction. So if the vectors are moving in x direction, I cap is a unit vector. If the vectors are moving in the y direction, j cap is a unit vector, and if the vectors are moving in the z direction, the unit vector is k cap. Here we are just considering in this first example, the two vectors are moving along the x direction. So that for vector A, the unit vector is I cap, and for the vector B, the unit vector is I cap. So we have the same unit vectors for A and also for B. So that why ma'am is there any need of multiplying this unit vectors? Yes, obviously dear students, so that you have while doing of the product. So let us discuss some numericals in the next class, that is what in the next part 4. So while discussing all those numericals, you will get an idea that why we are just going to write this third point in the note. So my dear students, now you can observe that I am just moving towards the third point. So I am just moving towards the third point. So you can observe that here both are in the same direction, right? Suppose even you can consider that the vector A is in y direction and also vector B is in y direction. Here you can consider that the vector A is in z direction and the vector B is also in the z direction. No issues. Suppose if the two vectors are in the same direction, that is what scalar product of I dot I, and scalar product of the two vectors j dot j and k dot k. See, you can observe here. Here we just what we did, we just multiply the two vectors a vector into b vector. What we got here? Here we got the value which is equal to 80. So ಅದನ್ನ ಮೊದಲು ಮಾತ್ರ ವೆಕ್ಟರ್ ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು. According to the definition, a vector dot b vector can be written as magnitude of the unit vector into the magnitude of unit vector into cos theta. But I dot I andre ಏನು? Both are in the same direction. If both are in the same direction, theta ಏನಾಗುತ್ತೆ? 0 ಆಗುತ್ತೆ. If theta 0 ಅಂದ್ರೆ cos 0 1. So ಹಾಗಾದ್ರೆ ಏನಾಯ್ತು? magnitude of I into magnitude of I ಅಂತ ಉಳ್ಕೊಂಡಿದೆ. So ಹಾಗಾದ್ರೆ magnitude of I ವೆಕ್ಟರ್ ಅಂದ್ರೆ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಎಷ್ಟಿರುತ್ತೆ? magnitude 1 ಇರುತ್ತೆ. The magnitude of unit vector. See, the word unit represents that the unit vector is having a magnitude 1. So ಹಾಗಾದ್ರೆ here it is of 1 into 1 which gives you 1. Right? Hope you are getting. So here we have the two vectors j dot j. So j dot j ಅಂತ ಇದೆ. So how to multiply this j dot j, my dear students? So these are all unit vectors. Unit vectors are always written with a cap, right? So now, so j dot j. So according to the for this one definition, so magnitude of unit vector into magnitude of unit vector into cos theta. But j and j both are along y axis. ಎರಡೂ ಕೂಡ ಸೇಮ್ ಆಕ್ಸಿಸ್ ಅಲ್ಲೇ ಇದೆ. ಬಟ್ ಎರಡೂ ಕೂಡ ಮಧ್ಯೆ ಇರತಕ್ಕಂಥ ಆಂಗಲ್ ಎಷ್ಟು? 0, because both are moving in the same direction. So that the cos 0 ಅಂತ ಆಗುತ್ತೆ. So cos 0. Cos 0 is 1. Magnitude of j is 1. Magnitude of j is 1 into cos 0 is 1. 1 into 1 into 1 is 1 itself. So that similarly for k, do the same, will get which is equal to 1. So what I am doing, so therefore I dot I is equal to unit vector j dot j, that is what the unit vector k dot k is equal to 1, is equal to 1. Yes, you should remember this, because while solving some numericals you will know this idea to solve it very easily. Yes, this is what happened now. And my dear students, now let us move to the fourth point. So you know that suppose if the two vectors are mutually perpendicular to each other, that what we did in the second case, example, second point that we discussed, that is what the angle between the two vectors a and b is equal to 90 degree. So ನಿಮಗೆ product ಏನಾಯಿತು? 0 ಆಯಿತು. You got the product which is equal to 0. Similarly, my dear students, suppose if I want to multiply I dot j, I vector dot j vector, j vector dot k vector, k vector dot I vector. See, this is the fourth point. Please be careful. I is the unit vector along x axis, j is the unit vector along y axis. And x ಮತ್ತು y axis ಏನಾಗಿರುತ್ತೆ? Always they are mutually perpendicular to each other. ಅಂದ್ರೆ mutually perpendicular ಇವೆರಡರ ಮಧ್ಯೆ ಆಂಗಲ್ ಎಷ್ಟಿದೆ? 90 degree. Similarly, j dot k ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So ಏನಿರುತ್ತೆ? If it is in this way, so ಇದರ ಹೊರಗಡೆ ಮತ್ತೊಂದು ವೆಕ್ಟರ್ ಆಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ ಈ ತರ, right? It means this is x, this is y, and this is z. So along z axis we have k vector. So it means this is z axis. So y and z are always perpendicular to each other. So that j and k are perpendicular to each other. The angle between j and k is 90 degree. Similarly, k dot I, the k and I, this one x and z axis are perpendicular to each other. The angle between this k and I is 90 degree. Hope you got. If we consider this product, so what happens here? The angle between them is equal to 90 degree, right? So now it can be written as magnitude of I into magnitude of j into cos 90, whereas the cos 90 is equal to 0. So 0 into anything becomes equal to 0 itself. Similarly, j dot k and k dot I is equal to 0. So that I dot j equal to k dot I is equal to 0. So that the product of I dot j, j dot k dot I is equal to 0, and the product of I dot I, j dot j, k dot k is always equal to 1. This is about the scalar product of the two vectors. Okay. Now my dear students, now let us move towards the discussion of the vector product of the two vectors. Vector product of, next heading, two vectors. Here the vector product is also called as cross product. Here the product of two vectors gives you a vector quantity, but there in this case of scalar product of two vectors gives you the scalar quantity. Yes. See my dear students, here I am going to consider, right, I am going to consider the two vectors. Consider that the vector A and the vector B, right? So which is having a unit vector n cap, and the angle between these two vectors is said to be theta. Then how to define the vector product with the cross product of these two vectors? Dear students, you can observe that. The unit vector, in this case the unit vector is perpendicular to the two vectors which are oscillating here. See, I am just repeating you. Unit vector is perpendicular to the two vectors A and B. A and B ಅಂತ ಎರಡು vectors ಇದೆ. So ಈ ಎರಡು vectors unit vector ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ perpendicular ಆಗಿರುತ್ತೆ. Now let us define that. How to define the vector product? So the vector product of two vectors is defined as the product of magnitude of the two vectors and sine of small angle between them. This is what the definition for the vector product of two vectors. Then how to write this? See here, after this line in your notebook, take down the line. If the two vectors A and B are acting at the same point with an angle theta, then yes, ಈಗ ನಾವೇನು ಫಾರ್ಮುಲಾ ಬರೆದು ಮಾಡ್ಕೊಂತಾ ಹೋಗ್ತೀರಾ. Okay, so here I just represented the diagram already. So how the vector product is defined? So ಎರಡು vectors ಇರುತ್ತೆ. So my dear students, I have the two vectors A and B. How to write the cross product? See, align ಮಾಡ್ತಾ ಇದ್ದೀವಿ, dot ಅಂತ ಬರೀತಾ ಇದ್ದೀವಿ. Here we are using our, we are representing it with cross, that is into mark. This is equal to product of magnitude of two vectors. We are multiplying the magnitude of the two vectors A and B. Here the magnitude multiply with that sine of angle between them. It is what? Sin theta. We should not stop here. For these two vectors, we have an angle. That is what the unit vector, which is represented by n cap, which is perpendicular to this two vectors. So the A cross B vector can be defined as the scalar vector product of two vectors, or a cross product of two vectors, or a cross B can be written as magnitude or product of magnitude of two vectors into n cap into sin theta. Right. So now, what's the example for this? See, after this, where A and B are the two vectors acting at the same point, theta is angle between the two vectors, n cap is a unit vector perpendicular to the two vectors. So already I said and matte bareytira ನೀವು. So then what is an example? See, velocity is a vector. So which is equal to the cross product of, see, omega, see, W ತರ ಬರೀಬೇಡಿ, omega cross r. Omega ಅಂದ್ರೆ angular velocity, r ಅಂದ್ರೆ, see, you know that distance ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, so position vector ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, so simply ಆಗಿ r ಅಂತ ಬರೀತೀವಿ. So velocity is equal to omega plus r. So whereas omega is a vector quantity, r is a vector quantity, we'll get velocity as a vector quantity. So v is equal to, how to write this? Omega r sin theta into n cap, where theta is angle between omega and r. In the next line, right, where r is the radius vector, r is the radius vector, omega is the angular velocity, theta is the angle between angular velocity and radius vector, n cap is a unit vector perpendicular to the two vectors. Yes. See, my dear students, the two vector quantities are multiplied to get a vector quantity again. So velocity is a vector quantity. So we just got the velocity by multiplying of the two other vector quantities. So we just discussed about the scalar product, vector product, and also the expression for that direction of vectors, direction of a resultant vector for the two component vectors acting in the same initial point. So these are all the things that we discussed today. So hope you all written well, and hope you all understood the concepts in a very clear way. So in the next class, let us solve some numericals on scalar product and vector product. Thank you, dear students. Have a nice day.